Hi guys, this is the now horizontal compression or horizontal stretch. And the previous one was about the vertical. So horizontal one is a slightly different from the vertical, but the rest is about the same. Okay, so let's actually take a look at this one. So we're still using the same graph as above or before. So in this case, we have f at 1/2 x. Now let's try to find what the f at 1/2 x is. Now hopefully you notice that this 1/2 is attached to the x directly inside of the function, not the outside like 1/2 sitting in the front. So that's the difference between what's whether it's the vertical, whether it's the horizontal. Anything that is done horizontally will be sitting inside of the function, which is the brackets in this case. So now if you have x as a -8, then this becomes 1/2 times -8 inside of that, and that gives me f at -4. But according to our original graph, f at -4, what is f at -4? It was 1. And same thing over, so we have 1/2, and then x is the -4, so we multiply that to 1/2 inside. That becomes f at -2. Now, according to our original graph, f at -2 was 2. And same thing happens again, 1/2, but instead of -4, we have +2 for the x value. So we multiply that to 1/2 inside of the brackets. So then it will be f at 1. Now f at 1, what is f at 1? It was at -4. Lastly, then x being 6, so 1/2 times 6 gives me f at then 3. F at 3 was 3. So let's actually plot this new graph. So when x was at -4, it is still at, and x was -8, it was at 1. So x is -8, it was at 1. Then x is at negative, I believe, 4. Then it is at 2. So -4, and it is at 2. Now, then the next one then says x is then 2. Then the y is at -4. So it's right here. Now, then last one is x at 6, then it's at 3, so it's right there. So let's actually take a look. If I draw the lines nicely, there we go. So I think it's actually better than I thought in terms of the straight line. And well, it's good enough. I don't have the ruler for this one. So hopefully you can see it. The graph actually is stretched sideways, right? It's actually stretched sideways. And hopefully you notice it, that see that -4, the initial x value, became -8, which is actually doubled in terms of the x value. Are we okay with this? And so hopefully you can see that if the value, the b value in front of the x is less than 1, regardless of what the sign is. Again, the sign only affects the rotation of it or reflection of it. Okay, so the number, the absolute value of the b, if that is less than 1, it seems like it's stretching it. Okay, how much does it stretch? It actually stretches it twice in terms of the lengthwise, right? Now, then let's take a look at this one. So obviously from the previous one, we can kind of like guess that this 2, the b value, will probably make our graph like half of the length of what we had before. So let's actually examine it. So if we have x as -2, that means it's 2 times -2 inside of the function. That gives me f at -4. But f at -4 again was 1. Now f at 2 times 1, sorry, -1, then that gives me f at -2, which gives me 2. And then f at 2 times 0.5, this gives me f at 1. F at 1 was -4. And then f at 2 times 1.5, that gives me f at 3. Well, f at 3 was 3. So let's plot these. So when x equals 2, sorry, -2, it was at 1. When x equals -1, it was at 2. And when x equals 0.5, it was at -4. Now lastly, when it was 1.5, it was at 3. So it's like this. Then my graph looks like that. So hopefully you can see it. The graph is like compressed sideways. Okay, so the graph is compressed sideways, and hopefully you notice it. Like take a look. It was at from -4. and then now it shifts to the -2 in terms of the starting point. And you can see that it's from, let's say, 3 then to 1.5. So this means that the whole graph actually is compressed by a factor of 2. It is actually compressed in half, right? So let's then conclude this. So if you have the absolute value of b, meaning regardless of what the sign is, just the number itself, if the b is greater than 0, it will be horizontal compression by a factor of. Now remember, the whole length became half of it. So by a factor of means you're multiplying something to it by a factor of, well, in this case, half. So it will be 1/2, but in this case, we're just dealing with the b, so it is b. See that it was at f at 2x, which means that my b value was 2, but that gave me the half, the length of it, but the half means it is 1/2. So hopefully you can see the relationship there, that it is the reciprocal, right? So our relationship that we have to put it here should be the reciprocal of the actual b value. Now then, what about the stretchwise? Well, take a look at the stretchwise. Here we stretched it twice as long as before, so the 1/2 became 2, well, because it's a twice, isn't it? So it was twice longer, but twice means actually 2. So if you look at it, it's 1/2 became 2. Well, 2 is kind of like 2/1, so it's also reciprocal. So when you are taking the horizontal compression or stretch, it actually works in, let's say, reciprocal way compared to the vertical. So then it will be horizontal stretch by a factor of 1/b. Okay. Again, if the b is less than 0. Sorry guys, it should be less than 1, not less than 0. Okay. If the b is less than 1, then it's a horizontal stretch, and if the b is greater than 1, it's a horizontal compression. Okay. So in general, I cut the C and D here for now. So if the A is vertical stretch, if A is greater than 1, or the absolute value of the A is greater than 1, and or compression, if the absolute value of A is less than 1. Now K then is horizontal, right? Horizontal stretch if B, absolute value of B is less than 1, or compression if the absolute value of not A, B is greater than 1. So don't get confused, okay? The vertical and horizontal, they actually work in the opposite way. Now if the A is negative, then reflection, right? On the x-axis. If the B is negative, then it is the reflection on the y-axis. So hopefully this summarizes of what we did in class, okay? So this was the horizontal compression and stretch, okay? Now that's pretty much it. That was the lesson for 2.5, okay? So hopefully it was helpful for you. Hopefully you understand this, okay? If you don't, please come to me for extra help. Okay, bye guys.